Hello. This is our second part of our lesson on ellipses and circles, technically. We're going to be discussing eccentricity, and I think there's a little bit of completing the square going on in this lesson. It's just the second day of ellipses, so if you want to take that for it's the harder part of the lesson, then okay, but it's just different. It's not more difficult. Alright, so there's some things we're going to be doing as far as learning targets and what's going to be on our next summative. Same formula that we used on the previous lesson for ellipses. We have vertical and horizontal ellipses, some more vocab coming today with eccentricity, but it's related to something we already kind of know about, which are the A and C and B values. And then, excuse me, a little sick today. We have to remember words like major axis and minor axis, and the foci. Alright, so this equation here, this is in general conic form. And they did kind of give us a spoiler alert that it is an ellipse, but we're going to find out that it's an ellipse once we complete the square on the x's and the y's. So let's go ahead and do that. Let's complete the square with the x's first, and I notice there's a common 4 we're going to have to factor out. Let's go ahead and do that. X squared, that'll be a minus 2x, which we will complete. Then for the y's, I see we're going to have a common 9 we're going to need to factor out. So that's a y squared minus 4y, and we'll complete his square. And like always, I wrote too large, so now I'm going to run out of room. That 4 is going to need to move to the other side. Technically, we could use it in completing the square, but we have a factor of 9, so actually, it doesn't matter, guys, if you want to use the 4 or not. You just have to be careful whether you've used it or whether you have not. So since apparently I can't pay attention to any detail, I'm just going to go ahead and move that 4 over. And then we have our other blanks that we're going to be adding in here. Alright, let's talk about the number that goes in this blue blank here. Half of negative 2 is negative 1 squared is 1. So this is a 1, but it's really a 4 because of that multiplier. So there we go. And then this blank right here, this is a 2 squared 4. So I'm going to put a 4 here, but it's really a 36. So in the blue set, we have 4 times x minus 1 quantity squared. Plus, in the green set, we have 9 times y minus 2 quantity squared equals, these 4's cancel, so equals 36. And then if I divide everything by a 36 to get it in that standard form for an ellipse, we end up with 4 over 36, so that's a 9 in this denominator. Plus, this is a 4 in that denominator. Just don't forget your squared, and then equals 1. So it worked out so that the major axes is already lined up in the first term here. I think there's a problem coming up where if we don't move terms around at first, the major axes, like it's backwards, but we're going to be able to tell what's going on really quickly. And if you remember, I kind of take like a graphical approach to these as far as how to plot things and where the major and minor axes are. So I'm not real hung up on formulas is my point there. Alright, so our center is located at 1, 2. And then our A value, the length from the center of the major axis to one of the endpoints, one of the major axes vertices, is 3. Square root of this is 3. And then the B value, the minor axis, half the length, is 2. Square root of 4 is 2. And then at some point I'm going to have to calculate, oh, you know what? It doesn't ask me to find all the other stuff, like foci and everything, but I think it's a good review for us. So let's go ahead and calculate the value for C, which we know for ellipses are a squared minus b squared. So if I go ahead and set that up and I square root, we end up with C equals, where are we at? 9 minus 4, so it's the square root of 5. If you want to convert that to a decimal, you sure can. Apparently I never did, and I'm too lazy to get out a calculator right now, but I know it's 2 point something. Okay, that's good. Let's move on to find our major axis vertices. So this is a, what do we got here? We got a horizontal ellipse. So the vertices are at the formula, excuse me, h plus n minus a, comma, k. So for us, those vertices would be at 1 plus n minus 3, comma 2. So I don't like when they're in that notation. I like to break them apart. 1 plus 3 is 4, comma 2 And then 1 minus 3 is negative 2, comma 2. And then similarly for the co-vertices, these are the minor axes ones. So the formula for a horizontal one would be h, comma, and then k plus and minus the b value. So for our information, we have 3, comma, 2 plus and minus, nope, no, Bruzo, back up, getting my numbers confused. H was 1, 1, comma, 2 plus and minus 2, there we go. So our co-vertices are at 1, comma 4, and 1, comma 0. Alright, which all of that I would have figured out because I would have just graphed it. So let's see what's going on here. Our center is at 1, 2. Finally, we have a graph that's not counting by 2s. How excellent. Alright, and then our major axis, the horizontal axis, is 3 units for a value, so 1, 2, 3. And then we'll back 1, 2, 3. And then remember, these were the major axes vertices, so they did get plotted at 4, 2, and negative 2, 2. So, yay us. Alright, your co-vertices would be in the vertical direction, distance of 2 units, so up 2, down 2. And then there's no way I'm going to... I should really approach these with confidence. Maybe that would help my drawing. It's not going to help my drawing. I'm really bad at these. Okay. So... there we go. Alright, let's talk about where the foci are located. So for a horizontal ellipse, there we go. Your foci are located at h plus n minus the c value, comma k. So it's a distance of square root of 5 on the major axis from the center. So for us, that would be, my h right this time, 1 plus n minus the square root of 5, comma 2. So along this major axis, I'm going like a little more than 2 units, so like, I don't know, somewhere right there. It wouldn't matter anyways, my graph is so ugly, nothing would be symmetrical even if I did that string and pencil trick they were talking about in the last lesson. Alright, I still wouldn't do a good job. Alright, so it looks like we found everything. We overachieved a little bit. It didn't say to find all that stuff, but it's good practice for us. Alright, moving along. Oh man, another one. Alright, good times. So, we're not in standard form. We're going to need to complete the square again, just like we did on the previous problem. So collecting my x's together, and I'm going to kind of save myself some time by factoring out that 25. Alright, so this becomes x squared minus 2x, and you know what, while I'm at it, I'm going to go ahead and fill in the blank here. That's a 1. Negative 1 squared is 1. Plus the y squared terms, or the y terms, we're going to factor out a common 9, and we end up with y squared minus 10y, and then in that blank, that'd be a 25. And then I'm not willing to mess myself up here, so I'm going to go ahead and subtract the 25 over. Even though I think I could have used it. Oh well. Because let's talk about what's in these blanks. In this blue blank, I have a 1, but remember it's being multiplied by 25. So I'm really adding another 25 there. That's why I say I was a little silly, but you know what? I know what I mess up on, and that's one of the things I mess up on. Oh my gosh. 225? Yeah, because 10 times 25 would be 250. 1 less 25, 225. Okay, we'll go with that. Alright, so we have 25 times x minus 1 squared plus 9 times y minus 5 squared equals 225. Alright, dividing everything by 225, so I can get, I'll write them underneath the terms this time so I don't confuse anybody. This is not technically mathematically accurate what I just did. Let's erase some of these lines here. There we go. Alright, 25 over 225 is 9. I just discovered that when I did my multiplication problem. So this term becomes x minus 1 squared over 9. And then 9 over 225 would be 25 in that denominator. This is the one I was referring to where it's backwards because of the way we collected, which is fine. Commutative property of addition and all says that I can reverse terms if I want to. So if it bothers you that these are not in the right order, you sure can switch these around. Just make sure that the 25 stays on the major axis with the y. So that means our a value has to be the larger axis, the major axis. So half the major axis is 5. The square root of this is 5. And then the b value is 3. And then the center of our ellipse is at 1, 5. So So all of the next pieces could be found through graphing your major and minor axes. But I know some of you really like formulas, and we're going to need to use our formula a little bit more today because of like finding the equation of the ellipse. So let's go ahead and use our formulas to find the major vertices and the co-vertices. Alright, so our major axis vertices for this will be a vertical ellipse, would be at the formula h, comma, k plus n minus a. So for us, that would be at, let's get this right this time, 1 comma 5 plus n minus 5. So that gives me the ordered pair 1 comma 10. Whoops. And 1 comma 0. Alright, so there's my major axis endpoints, those vertices. Now let's find our co-vertices, which would be on our minor axis. So for a vertical parabola, ellipse, it's Friday, can you tell? Alright, the formula would be at h plus n minus b, comma, k. So for our information, that would be, I got numbers all over the place, 1 plus n minus 3, comma, and then 5 is going to stay the same. So our ordered pairs are at 4 comma 5 and negative 2 comma 5. Alright, and this is all great information. I'm going to be plotting them all, but instead of just blindly plotting and following, what I'm going to do is plot them through what I know about the ellipse formula in standard form, and then I'm going to double check that in using all those formulas we just found that I did indeed do everything right. This would be a good moment to like figure out if you use the wrong number like I always do. Alright, so my center is at 1, 5. And then the major axes is 5 units in each direction from the center. So 1, 2, 3, 4. Oop, off the screen. Yeah, well. So that would have been at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is where it was supposed to be at 110. Cool. Alright, moving down 5 units. 1, 2, 3, 4, 5. And then for my minor axes, it's 3 units from the center on the minor axis length. So horizontally 1, 2, 3, and 1, 2, 3. And I didn't double check that pair, but that is 1, 0. And then these minor co-vertices are at negative 2, 5, and 4, 5. Alright. And now I'm going to ruin it all by trying to graph. Yeah, oh, you know. Yeah, I'm going to say I finished real strong on that one. I'm gonna call that a win. If I could just sneak in here and maybe pretend, oh, no. Alright. I do this every time. Like, I try to fix it and I make it, actually, that's a little better than it was. So, again, I'm going to call that a win. We haven't found the foci yet, though. So C, the distance along the major axis that we're going to count from the center to plot the foci would be the square root of a squared minus b squared. Oh, for Pete's sake. Nothing's working today. Alright, so square root of a squared minus b squared would be square root of 16, which is 4. I can do that. Alright, 1, 2, 3, 4 units. There's one foci. 1, 2, 3, 4. There's another foci. And if you want to use the formula for finding foci on a vertical ellipse, that would be at the formula h, comma, k plus n minus c. So, for us, oh gosh, h is 1, k is 5, and we just found c is 4. So my ordered pairs become 1 comma 5 plus 4, which is 9, and 1 comma 5 minus 4, which is 1, which are indeed those 2 green points that I just starred in there. So, go us. We did great. Alright, moving along. This is a problem. This is just like a bonus problem here. It is not on your notes. I have some kids coming in a minute, so if you don't mind, I'm going to save this one for the live class lesson, and we're going to go back to our notes here. I'm going to do this question with you. This time they don't give me all the clues I need. They give me some information that I can use, though, so that's nice. They tell me my vertices, and then they tell me where the foci are located. And that should be enough information to write the whole equation, right? So if I think about what they're telling me here, you know, I like graphs, so let's look. Negative 12, 6, pretend it's there. And then 4, 6. So we're going to have a major axis that is a horizontal piece, so we have... oh, great job, Abruzzo. perfect. We have a horizontal ellipse. So we're going to be using the formula, the horizontal version of it. So x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, so if I think about things I need and things I have, they didn't outright tell me where the center is, but I'm pretty sure I could figure out the center because it's going to be in the middle of this major axis. So let's do a quick calculation to find our center. It's going to be in the middle of these 2 points, and I already know the y value is going to be a 6. That's not a big mystery. But the midpoint between negative 12 and 4 would just be to find literally the midpoint, add them together, and divide by 2. So negative 8 divided by 2 is negative 4. That would be 8 units in each direction, which we just found something else. I'll talk about that in a minute. But we just found our h and our k. So if you want, you can kind of, in this formula, throw a negative 4 and a 6 right here. I still need a and b, and once I have a and b, I'm good to go. I think we actually stumbled upon a. So the a is the distance from the center to the major axis for one of the vertices. There we go. One of the major axis vertices. So if this was at negative 4, we just found, and then you can go to either endpoint, it is a distance of 8 units from either endpoint. So the a value is a distance of 8 units. So when I go to the formula here, we're going to plug in a equals 8, and we'll get a 64 down here. That was just a. I should probably mark that so I don't get confused. The foci, however, that's another important clue, right? Because the distance from the center to either of the foci is a distance of c. So if the foci is like out here at negative 10, 6, and the center was at negative 4, that's a distance of 6 units. Now, what I just found was c. c equals 6. I could have totally done a formula, by the way. Those of you who don't like to look at pictures and graph things, more power to you. But that's probably the easiest way. But we can go back and look at the formula if you'd like. Remember, the formula for a horizontal foci is h plus or minus the c value, comma k. So if you knew, you already knew what k was, it's boring. But this is the clue that we could look. Now clearly this is the minus version of that formula, h minus c equals negative 10. So since I know h is negative 4, I could say negative 4 minus c equals negative 10, and then I could solve for c that way. So subtract 4 and then divide by negative 1. So either way I get c equals 6. But I think we can all agree that, like, as long as it's easy things that we can count and visualize, like graphing is probably the way to go. I realize they're not always going to be pretty though, so we got to be okay with that. Alright, anyways, I'm going to get rid of that. I think we're almost home free, guys. Because now I can use the formula c squared equals a squared minus b squared, because I know c and a, so I can solve for b. So c squared would be 36, a squared would be 64, and then I can solve for b. So, since apparently I can't subtract today, that's negative 28 when I subtract those. 64 over equals negative b squared, so obviously I'm not going to be dividing by, not going to be square rooting until I divide by a negative 1. So b is the square root of 28, or you can just say b squared equals 28, because that's all I really need for this formula, right? I think we're good to go, guys. Let's plug everything in that we need. So in the formula, x minus negative 4 would be x plus 4 squared over 8 squared, which is 64, plus y minus k, which is y minus 6 squared, over b squared, which we just found is 28, equals 1. All right. So the trick was, looking at what you were given, what you could calculate, and then what took a little more effort to calculate. And the foci clue is important because it tells you a clue about the distance of c. But that's not even part of the formula, but we had to use c to find b. So that's what we're going to have to run into today, huh? Let's look at number 4. This is on your notes. We'll go ahead and do that. They're different set of clues this time. They gave me some vertices, and then the length of the minor axis is equal to 10. So that is their way of kind of sort of telling me the b value, because remember the b value is half the length of the minor axis, so that means b is 5. So it would be this guy cut in half. So I'm going to keep that as a note. The vertices, negative 2, negative 4, and again, I really like sketching a really ugly plot, I guess apparently, or negative 2, negative 4. and negative 2, 8. So we have a lovely vertical ellipse. Totally looks like a caterpillar cocoon. So ugly. Alright, so a vertical ellipse is going to be in this formula. So y minus k squared over a squared plus x minus h squared over b squared equals 1. So again, I think they didn't outright tell me the center, but I think we could figure out the center pretty easily because it's just going to be the midpoint here. So your center is going to be over negative 2. That's not going to change. But the middle of negative 4 and 8 would be, add them together, 4 divided by 2 is 2. So our k value is 2, our h value is negative 2. And then we kind of already knew from that last clue there that b was 5, so b is 5. It's important. And let's see. Oh, I think we know a. Awesome. Because a is half the distance of the major axis. So the major axis is a distance of 12 units, right? So a value would be a 6. Alright, let's rock and roll. We have y minus 2 squared over 6 squared, so 36, plus x minus negative 2, so x plus 2 squared over 25 equals 1. That was even easier than the previous one, I think. I don't know, maybe not. Alright, so we didn't even have to consider the foci or the value of c because all they wanted was the equation. So, good to go. If I had to graph it and then plot the foci, I'd have to do more work, but good news all around. We don't have to do any of that. Alright, let's talk about, number 5. That's a good one. Alright, so they went ahead and told me the 2 foci, and then the length of the major axis is 10 units. So I really need a visual for this one. And it's going to be a grand visual, like always. Nope, it's not even a good one, because it's way up here at 1 and 7. Alright, so let's give ourselves a more appropriate scaling here. So negative 2, 1, like right here maybe, and negative 2, 7 up here. And those are the foci. So the ellipse itself is looking something like this. That was really good. Go me. Alright, so, excuse me. The distance between the foci, that might be something to consider, you know? Because that's going to help me figure out a couple of different things. First of all, the distance between these 2 foci from 1 to 7 is 6 units. And then they told me the length of the major axis, which is the same axis that the foci are along, is 10 units. So that tells me that there's like a little pieces of 2 and 2 up here and here. So this is 2 units and this is 2 units, because I would have to add up to 10. Alright, so all that information is very interesting. But we have to figure out what we actually have here. And, ooh, alright, I'm going to start writing the formula down. I think we actually have quite a bit of information here. It's a vertical ellipse, so y minus k squared over a squared plus x minus h squared over b squared equals 1. I think we know the center after we do a little bit of work. I think we know a. I think we know c. And I think we could calculate b, because that's all we need. Alright, let's do this. So the center is going to be, and you can think of it literally in the middle of the 2 foci, because it's actually in the middle of the foci, or the middle of the major axis. So it seems pretty easy to find the middle of the segment that connects the 2 foci. That would be at negative 2, comma 8 divided by 2 is 4. So we just found h and k, important. So h is negative 2, and k is 4. Awesome. The a value is half the length of the major axis. So if the major axis is 10 units, that means your distance of a is 5 units. So this guy right here is 5. And then the other clue they gave me, like, they really didn't talk at all about the minor axis, but we know that we could calculate c, which is the distance from the center, which we now know is at negative 2, comma 4. Oh, you can't read that at all. Let's try that again. The center is at negative 2, comma 4. Oh, I had it right here. Alright, and then the foci, which I did not label very well. Like, let's do this one. This is at -2, 1. So how far apart is the center to the foci, this focal point? And that would be 3 units. So that is the length of C, which means C squared is 9. So now with A squared and C squared, I can find B squared. So using my formula, C squared equals A squared minus B squared. And all I need to do is solve for B squared, because they just want the formula. C squared is 9, A squared is 25, minus B squared, so that would be -16 divided by negative. Alright, so B is 4. Oh, why did I do that? I don't want that. I just want B squared. B squared is 16. There we go. We're good to go. Let's plug everything in. Y minus 4 squared over 25 plus x minus -2, so x plus 2 squared over b squared, which is 16, equals 1. Love it. Oh boy. Alright, one new topic. It's kind of a hard one to visualize, but once you look at the formula, it kind of makes sense. Eccentricity. So eccentricity is basically measuring how circular your ellipse is. It's the distance between the foci divided by the distance between the vertices. Okay. So the eccentricity formula that they're going to have you use here is just C divided by A. Okay. So sometimes that's confusing to kids because they're like, well, wait, the distance between the foci isn't just C, it's like 2C. But that's true, but the ratio would reduce to C over A. So 2C over 2A, the 2's would cancel in the ratio. So this is the simplest formula we have for eccentricity. Oh, here, this is what I need. If your eccentricity value is between 0 and 1, you have an ellipse. If it equals 1, you have a parabola. And if it's greater than 1, we have a hyperbola. And then there's a little note at the top here that says, well, what if the eccentricity is 0? That means you have a circle. That is not looking right. All right. So a circle, an ellipse and a circle, really the formula feels the same. But we have to realize that by definition, a circle doesn't have like a major and minor axis. They're the same because of the diameters being the same. So let's see what happens. Oh, this is a nice visual here. So we have a 0.94 eccentricity ratio value, and you end up with this elongated ellipse here. But look what happens. The closer and closer and closer you get to 0, the more circular your ellipse becomes. So basically, eccentricity is a measurement of how circular your ellipse is. Alright, so if we find the next problem on our notes, I'm going to skip to there. Right here. It says determine the eccentricity of the ellipse by the equation. So the eccentricity formula is C over A, and we don't know C yet because we're going to have to calculate that. So for an ellipse, C is the square root of A squared minus B squared. So 25 minus 16 would be square root of 9, which is 3. So C value is 3, the A value is this guy square rooted, so 5. So the eccentricity for this particular ellipse is 3 over 5, which is 0.6. So not at all close to a circular ellipse. It's going to be very elliptical, if you will. Alright, number 7. Eccentricity, same formula, C over A. And I don't know C yet, but if I calculate it, it is square root of 64 minus 9, so that's the square root of 55. Which I didn't convert to a decimal, so we'll just go with it. Square root of 55 over A value, which will be square root of that, which is 8. Now, if I wanted to, you know what, I'll just calculate the decimal. Why not? Square root of 55, that should be 7 point something. And then divide by 8. The decimal that this ratio comes out to is 0.92. So this is a very circular ellipse, in fact. If it was me graphing it, it probably looks close to a circle, because I can't graph. Alright, so that's the idea of eccentricity. It's not a super complicated topic as far as using it and calculating it. The derivation of it's kind of fun, but we're going to skip that for now. The back of this worksheet is going to be your homework, but I do want to do one problem with you. I think it's That's a creepy problem. Alright. Apparently in class we're going to do a question about an eyeball. That's exciting. Oh, you know what? This might be in your homework too. This is a great question because it is a really cool application of eccentricity and elliptical things, which is your eyeball is elliptical in shape. If you look at a cross-section of it. Alright, number 9. This is the one I want to look at. The shape of a sign is an ellipse. And I can't read that. The eccentricity is 0.6. And the length is 48. So, they want me to write an equation for the ellipse. At the center is at the origin, and the major axis is horizontal. So again, I have this formula for the ellipse. So, the center is at 0, 0. That's an easy one. So h and k are 0, 0. And then it tells you that the eccentricity is 0.6. So 0.6 equals c divided by a. The length of the sign is 48 inches. So we have this, not ellipse, this length here is 48. And remember the a value is half of the major axes. So the a value in our sign is at 24. So if I plug that into my equation here, I can solve for c because it's just a proportion. So multiplying both sides by 24 times 0.6 is 14.4 apparently. Alright. So we know a is 24, we know c is 14.4, and in order to write the equation, I have h, k, and a, I just need to find b. So we're going to use our c squared equals a squared minus b squared formula. I'm just going to rewrite, I'll write it like this. C squared equals a squared minus b squared. And I just want b squared, so remind me not to square root, everybody. Alright, c squared is 14.4 squared equals, a is 24 squared. So I would subtract 24 squared, divide by -1, of course, and that comes out to roughly, or exact, I'm not sure, because I don't have it up on my calculator anymore. 368.64 is b squared. Now if you went ahead and square rooted, it's like 19 point something, but we don't want b, we want b squared for now. Oh, but we do want b in a second. I'll go ahead and write that down. It's 19.2. So my formula is, I'm going to write down here, x minus 0 squared, so x squared over a squared, so I'm just going to write 24 squared, plus y minus 0 squared, so y squared over b squared, which is 368.64. Should have simplified that, I suppose. 576, for those of you who are curious. And then equals 1. Then part B says, what is the maximum height of the sign? So that would be the distance to the top of the minor axis. So this is the length of the minor, half the length of the minor axis. So from the origin and then going up 19.2 inches, that would be the maximum height. So if I had a better picture, this would make more sense, but remember we have an ellipse at the origin. And then if the minor axis distance from center to the co-vertex is 19.2, that's where they're getting that max height of 19.2 inches. Alright. Okay. I think that's all I want to do in this lesson. Let's call it a day.